All right, so this is Business Cal 4.1, the last part, so part 4. And the actual percentage increase during 1 year is called the effective rate of interest, or the annual percentage rate, or APR, or the annual percentage yield, APY. So on the last example, that continuous rate of 15.8% used above gives a return of 1.171. And after subtracting the original dollar invested, that leaves us with a gain of 0.171, okay, on the original dollar. So that means this gain is your APR of 17.1%. Okay, so if there was a gain of, if we had a gain of 0.235, that would mean your APR would be 23.5%. The stated rate here, the 15.8%, is what we call the nominal rate of interest. So for this problem, the nominal rate of 15.8% compounded continuously is equivalent to an APR of 17.1%. And the 1993 Truth in Savings Act requires that banks always state that annual percentage rate in all of their stuff. All right, so the last little bit is about the function e. So this number e gives us a new exponential function. F of x equals e to the x, which is an exponential function. It's used extensively in business and economics and all other areas of science. So the table below shows the value for e to the x for various values of x. These values lead to the graph shown on the right. And you notice that e to the x is never 0. It's the same for all the other exponential functions. Your domain is all real numbers and your range is 0 to infinity. So it's never 0 and is positive for all values of x, even when x is negative. So to restate this, the important observation is that e to any power is positive. Now, we can have functions where our e has different values. Sorry, just 1 second. So the graph shows the function on slide 39. F of x equals e to the kx for various values of the constant k. For the positive values of k, the curve rises. For negative values of k, that curve falls. Okay, so you can have exponential growth and decay with the e function if the coefficient of x, so that e to the kx, if this coefficient is greater than 0, we have growth. If it's less than 0, we have decay. So we can still have an exponential growth and decay function with the e function. All right, that's the end of 4.1.